All right, in this video, I'm going to talk about vertical, horizontal, parallel, and perpendicular lines. First, let's start with vertical lines. Vertical lines are going straight up, straighter than that. But yeah, straight up and straight down. Just completely vertical. At a 90-degree angle from the x-axis, right? X-axis, y-axis, right? And the standard form of a vertical line is just x equals c. How do we get that? Well, let's just graph that and find out. X is always c. Let's just come up with a c for us. So let's just say x equals 4. Because that's the line I just drew. You think you'll find. So if x equals 4, then x is always going to be 4. Wait, that doesn't make sense. X is the input, right? How can we have the same input over and over again, and yet we'll get different numbers every time? Well, because it's not really a function. That's why we have the same input and we can get different things out. It's the definition of insanity, right? Doing the same thing over and over again and expecting a different result. This is actually insanity. That's why this is not a function. Vertical lines are not functions. That will be important later on, but not really in this lesson. So vertical lines, not functions. Okay, so, but they do have a slope. What is that, right? I mean, all lines have a slope. Well, let's try and calculate the slope by putting in some of these numbers. Rise over the run, right? Well, take any two of these points. Y minus y1, let's just take the first 2 points. 5 minus 3, right? 5 minus 3. And then for the x's, we get 4 minus 4, right? Well, something happens. 5 minus 3 is 2. 4 minus 4 is 0. Thou shalt not divide by 0. So the slope is undefined. Always undefined. For vertical lines. Does a vertical line have a y-intercept? Well, there's only one vertical line that has a y-intercept. That it would be the y-axis, right? And that would be x equals 0, right? And that's just the y-axis itself. And no matter what you put in for y, you will always get, x equals c. In this case, c is 4. But, you could have x equals whatever. It will always be a vertical line. Because how you graph this is 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right there. And if the x is always a 4, just go up and down that line there, because x is telling you how far away from that origin you are, and you'll just always be 4 away from it. All right, now I'm going to go over horizontal lines. Now, the standard form of a horizontal line is very similar to the vertical line, except instead of x equals, it's y equals c. Well, that was easy. But what is the slope? You know, is this a function? How would you graph that? Let's just say y equals -2. Let's go down 2, see what happens. Y equals -2. We put in -2. Y will always be -2. Well, if y is always -2, then x could be anything. We could plug in anything for x, and we will always get -2. Why is that? If it's the same as this, how is it still a function if it's still just so simple, right? I mean, it still doesn't look anything like our standard slope-intercept form, right? Well, that's where slope comes in. So whatever we put in here for x, we always get -2 out, right? How could we explain that? Well, let's find the slope of this thing. Just like we did with the vertical lines, let's find the slope of this horizontal line and see if we can make sense of this somehow if we do that. So just take any 2 points. Let's take these 2 points because they're the easiest. 1, -2. So y minus y1, -2 minus -2 over x minus x1, 1 minus 0. -2, and a double negative becomes a positive, so -2 plus 2 is 0. 1 minus 0 is 1. Okay, so our slope is 0. Well, if m is 0, and it's being multiplied by x, what are we left with? Because anything multiplied by 0 is just going to be 0, so it's just like y equals b. And if b could be anything, then y equals c. So c is b, kind of the same. It's just we just put c because it stands for the word constant. And by constant, it's just a constant number. It's always the same. X is a variable number that can change, especially in this case. Does that make sense? So, let's actually graph this. 1, -2, 0, -2, -1, -2, -5, -2, 5, -2. It's just a horizontal line. And if you have trouble remembering which lines, what horizontal and vertical means, horizon is in the word horizontal. So you look at the horizon, it's always kind of, straight across your field of vision instead of, straight down. So that's how I remember. I wish I had something to remember what vertical means, but as long as I remember what horizontal means and the vertical is the opposite, I'm good. So slope is always 0 for a horizontal line. One quick thing before we move on to parallel lines. Sometimes you'll be given one of these questions, problems on a test or a quiz, and your first thought is, oh, find the equation of line that passes through the 2 points. Oh, I got to use the slope formula with the y's over the run, and then I got to use the point slope formula. Y minus y1 equals m times x minus x1. Yeah. Oh, I got to go through all this complicated math to find that. Y equals mx plus b, right? Whoa, wait a minute. Think about it. Look at those 2 points. X is 7 in both of them. If you're putting in the same input twice and you're getting different outputs, then that is a vertical line, x equals 7. Same goes for horizontal lines. If you notice, the y's are the same, like, I don't know, 10, 2 and 3, 2. Got to notice that, and you don't have to go through all this crazy math. You can just say y equals 2, bro. That was easy. Your teacher might ask you to explain how you got that answer, but you could just say, hey, I mean, y is 2 in both points, so that's the answer. All right, next up is parallel lines. Now, what are parallel lines? They're not like vertical and horizontal lines. They don't have to be vertical or horizontal lines. Parallel is describing the relationship between 2 lines. Now, these very badly drawn lines are going to demonstrate that. First of all, let's look at this red line here. What is my y-intercept, first of all? Trying to fill out the blanks here. What's m and b? My y-intercept is 1, 2, 3, 4. It's at 4, right? Okay, so positive 4. Okay, what's the slope? Well, we go over 1, 2, 3. We go up 4, right? 1, 2, 3, 4. Okay, so rise over run. So we went up 4 and over 3. Okay, so 4/3 is our slope. Okay. Where am I going with that? Well, let's do the blue line first, and I'll tell you. What's the equation for the blue line? Y-intercept, -1. Slope. Well, we go up 1, 2, 3, 4. Okay, 4 is the same. And then over 1, 2, 3. Yeah. Okay. So up 4 over 3. Oh, I see. The slope is the same. That's what makes these lines parallel. What does that mean if the slope is the same? It means that these lines will go on forever and ever and ever, and they will never, ever intersect. They will never intersect. What does intersect mean? It means they'll never cross each other, never intercept. They both intercept the y-axis because the y-axis is a vertical line and does not have the same slope as these 2 lines. So they will never cross each other. That's what it means to be parallel. And you can remember that parallel means that because of the 2 L's in the word parallel. They're, straight up and down lines, and they, well, never intersect. So slope is the same. See how it's different from horizontal and vertical lines? It's not describing a line. It's describing the relationship between 2 lines. 2 or more lines. I mean, you can have other lines with the slope of 4/3. You just have to, maybe change up that y-intercept and you're good. Got tons of parallel lines. But if that slope was off by even a little bit, 5/4, then yes, those lines would eventually cross at least one point. Well, no, just 1 point, exactly 1 point. But they have the same slopes. One more thing about parallel lines before we move on to perpendicular lines. Since horizontal lines always have a slope of 0, if you have more than one horizontal line, guess what? Those are parallel. All the horizontal lines in the world will be parallel. Same with the vertical lines. Since they all have the same undefined slope, they will all be parallel to each other. All the vertical lines will be parallel to each other, and all the horizontal lines will be parallel to other horizontal lines. But what if you have a vertical line and a horizontal line? That's where perpendicular lines come into play. All right, finally we get to perpendicular lines. Now, this time I still have a blue line and a red line, but this time they intersect. Now, and I also included the equations that come with those, that red line and the equation that comes with the blue line. Now, we know they're not parallel because their slopes are different, and they intersect, obviously. But what makes them perpendicular, though? Well, they intersect at a right angle. How do I know that they intersect at 90 degrees, at an angle of 90 degrees? Because of the slopes. Well, I just said that the slopes aren't the same. So wait, what is the relationship between these two slopes? Well, there's a relationship called a negative reciprocal. Negative reciprocal. Whew. Okay, well, you understand the negative part easily enough, right? I mean, this one's negative and that one's positive, so they're opposite signs. Okay, that's easy to remember. But what's a reciprocal? Well, let's take 2, for example. A reciprocal of 2 would be if we flipped it. Flipped it how? What? You're flipping numbers now? Every number is a fraction, right? Even whole numbers, right? They're always understood to be over 1. So if I flip them, I get 1/2. 1/2. The negative reciprocal of 2 would be negative 1/2. And you can go back. Negative reciprocal of negative 1/2, you flip the 2 over again, so it's 2/1, and you put another negative in front of the negative that's there, and you get a positive. So this, too, is also a negative reciprocal of negative 1/2. That is how you know 2 lines are perpendicular. If you can find their slopes, you can tell from the slope. That is a negative reciprocal. All right, now let's put all that knowledge we just learned about parallel and perpendicular lines to the test. See, you might get a problem like this. This asks, determine if the lines are parallel, perpendicular, or neither. Well, we have 4 different lines here. What are you talking about? Well, let's just go through every single one of them. A to B, A to C, A to D, then B to C, then B to D, and then C to D. Okay, so what about A and B? Are they perpendicular, parallel, or neither? They are perpendicular, right? That's a negative reciprocal. So A perpendicular to B. There might be a symbol like that. Or you might say perpendicular with a dot, just abbreviate it. So A perpendicular to B. Okay, what about A to C? -5/2. A is neither to C. Okay. And what about A to D? -4/3, 3/4. That's perpendicular, right? That's a negative reciprocal again. So A perpendicular to D. All right, that's the first one. What about B? B to C. The first four, actually. B to C, 3/4 and -5/2. See how I'm ignoring the y-intercepts? Don't need them, because all we're doing is determining if they're parallel or perpendicular. Do we need to graph these to figure that out? No, because we know if the slope is the negative reciprocal or if the slope is the same, then we'll know whether it's parallel, perpendicular, or not, or neither. So B to C is neither. B is not parallel, perpendicular to C. I don't know. Usually, actually, it would be exclamation point is not. And maybe this would be a parallel symbol, and this could be the perpendicular symbol to C. Maybe you could use those symbols to demonstrate that B is neither to C. What about B and D? 3/4 X, 3/4. Oh, B is parallel to D. That was an awful looking D. Wow. Okay, there we go. B is parallel to D because they have the same exact slope, right? Okay, what about C to D? C is neither to D. Okay, those are your answers. That was easy. All you have to do is look at the slopes. That'll tell you. All right, one more example of a problem that you might get talking about parallel and perpendicular lines. They might ask you to write an equation for a line that is parallel and for a line that is perpendicular to the given line. That would be this blue line right here. And that passes through the point -4, 1. So they want two equations here. They want one for a parallel line and they want one for a perpendicular line. They're going to be parallel to this line. And this one's going to be parallel to that line, or perpendicular to that line. Now, what do we need before we can do that? We need the slope of this line. Can you tell what the slope is from here? Well, maybe some of you can, but I'm going to put it in slope-intercept form just to make sure we know what it is. So let's move that 4 over to the other side. And let's move this 5x over to the other side as well while we're at it. So we're left with -3y equals -5x minus 4. Divide both sides by -3. Y equals 5/3 x plus 4/3, but we didn't really need that y-intercept. We want this. So if we want a line that is parallel to that, then we know the slope is going to be 5/3. Okay. And we know that the equation of the line that we're trying to find is going to pass through that point, -4, 1. Let me just delete this here to make room. Let's just write 5/3 over here. That's our slope for this, and erase that to make room. All right, so we're looking for the parallel answer, right? So we need to use our point slope equation, right? Because we have a point and we have a slope. So y minus y1, that's our point slope form, equals m times x minus x1, right? The y1 and the x1 come from that point there. So y minus 1, because the y is on the left, is on the right side, right? M, well, actually, we know what m is, right? It's 5/3, okay? X minus x1, -4. Okay. Let's distribute this, and double negative makes positive, right? Leave that the same for now. 5/3 times x is 5/3 x. Good, our slope is the same, nothing's changed there. 5/3 times 4, well, whatever, 5 times 4 is 20/3. Okay. Plus 1, y equals 20/3 plus 1. Well, 1 is the same as 3/3, right? Got to have that common denominator. That was a weird look at 3. 3/3, so 20 plus 3 is 23. So that is half our answer. We got the parallel line that they wanted. Now let's do the perpendicular line. What is the slope of our perpendicular line? Instead of 5/3, it's going to be -3/5, right? And passing through that same point. So we got to do the same thing again with that point slope formula. Y minus y1, which is 1, equals m, -3/5, times x minus -4, which is double negative again. All right, now let's distribute that. -3/5 x plus, actually, no, it's a minus, isn't it? Because it's a negative times a positive. So, gotta make sure we keep our signs right. 3 times 4 is 12/5. Okay. And we still have y minus 1 over there. Add 1. Add 1. 1 is the same as 5/5. So, y equals -3/5 x minus -12 plus 5, -7/5. And that is our perpendicular line, and that's our parallel line.